Thank you very much for that introduction. I'm humbled by everything that was said. Everything I've done has been together with teams. You can't do all these things alone. And some of the things that I'm talking about today happened also before my time in that organization. First, about Cybernetica. Of course, the name comes from cybernetics, the scientific study of control and communication, as introduced by Norbert Wiener in 1948, for military purposes, because it turned out that humans were not very good at shooting down fighter jets. And so you had to build a machine to do it more efficiently. And all of that actually worked and worked and worked until we got to the point that this became a full subject of study. And in 1960, in Estonia, in the Academy of Sciences, the Institute of Cybernetics was founded. It worked on lots of things: logistics, planning, text analysis, voice analysis, pretty large research institution at that day and age. In 1997, there was a science research reform in the country, and the Academy of Sciences did not need institutes anymore. So Cybernetica was formed out of the people in that organization who wanted to build things. And here we are now, over 20 years later, and we do have some stories to tell. But I will get the GDPR joke out of the way. And for those who don't know about GDPR, I will explain what it is, and that will also help explain the joke. So the General Data Protection Regulation is a European regulation. Means that all European member states have it as a law starting from May 25th this year. And it also matters to a company or a service provider in another territory. If you have European users, then you must adhere to this regulation, meaning that a lot of these internet companies in Northern America have been forced to rethink their services, invest heavily into improving the privacy of their offerings, and get consent for everything. You actually, in order to process people's data, this regulation has consent as a key component. You need to ask the person if you're actually going to do something with their data. And the joke is several parts. The first is that around this last month, or a little bit earlier, if they were very mature companies, you could tell by the timing. People started sending emails. If you're a European, you got quite a lot of them, because every service provider needed to tell you that they have updated their privacy policy. And you would need to give them consent that they can continue sending you spam and using your personal data to sell you stuff and all of this. A lot of people did it, and it became so ubiquitous that people started making jokes, putting these we've changed our privacy policy text into all kinds of things. And here, a typical email like that has been rendered as the opening cinematic of almost every Star Wars movie. So this is the joke. And yeah, the point is, the claim I'm going to make today is that when did we go so wrong? So we need this regulation. The question is that people around the world survive without privacy regulation. Europe is not the only country where something like this exists, but Europe has one of the most ambitious projects, because privacy and data protection regulations exist in Japan, Brazil, other territories are adopting them. People are even talking about adopting them in the US. Wait and see. Okay, so, but something happened so that we actually need this. And let's start at the early beginning. So think of the first computer. I'm not picking the first computer. I picked the first programmable digital one, means that it has Boolean logic and it can be programmed. And that was the Colossus, built in the UK to break the Lorentz encryption device used by Nazi Germany at the time. The classic Enigma is a different encryption device, and the computer that was built to break that was the Bomba. So that's not the Colossus. But the Bomba was not a digital computer by today's terms. Actually, the Colossus was not Turing complete, for those who know what that means. Although there have been recently been papers that if you like chained 10 colossi together, then you could form something that is Turing complete. But this is a nice exercise. I don't think more than one or two exist in the world anymore. When you had one computer, or actually, yeah, they had 10, so because they needed to break a lot of codes at the time, security was not a concern. So you didn't need to build security into the computer architecture. It was just not a requirement. Ironically, the requirement was actually breaking other people's security. That's why the first computers were built. And this, on this picture, you have the Colossus picture courtesy of the history blog. So, and it did not get better from that. When they implemented the first packet-switched network routers, which is what is a precursor of today's internet. That was the interface message processor built by a US R&D organization called BBN, named after three gentlemen, today owned by Raytheon, in '69. That was the first router. It was pretty much a reprogrammed computer that just did message routing, very much similarly to all the Wi-Fi devices and everything we have today. Security was, again, not really a concern at the time. Getting as many nodes as possible on the network was the concern. Communication was a requirement. Security was not. And this picture comes from the Computer History Museum. So, and this went from there. When you have one computer, it's like you have only one person in the world. You probably don't have any problems. Well, there's certain ones, but you don't have much of a security problem. When you get two computers or two people in the world, then you get competition and you may get secrets. There might be a drive towards advantage. When you get these two computers to talk to each other, then you're creating value because some efficiencies can be created, but you also have a new leakage point in this communication line. And then you build, you continue building this whole network. This is where we're up to now. Everybody can talk to everybody at very high speeds. The problem is that because we didn't build security in the beginning, then today we have to protect every computer, every device, every node, and every communication channel separately. We have to patch security in step by step, inch by inch, finding a constant battle between people who are trying to break it and people who are trying to build it. And unfortunately, it doesn't seem that it's feasible to rethink computing today. There are attempts of building a new kind of computing architecture or network architecture, but changing everything in the world to that new platform, a little bit infeasible economically at this point in time. So that was the prologue. Today I will tell you a few stories about systems that have been built to be secure by design, how they have been built, and how people manage to build these systems secure by design, because that's not always what the customer asks for. We'll also hear a little bit about the technologies. And if you can think about these three things while I speak, how to build secure systems on insecure foundations, because we have insecure foundations. And once you learned how to do it, how can you get others to be able to do it? Because you can't do everything in the world alone. You have to teach. And how do you make security compelling to the organization who would be deploying the system in the end? How do you actually get them to think that, okay, maybe I should do something about this? So let's start with story number one. This is centralization versus decentralization in data architectures. You may have heard a little bit about that in recent days. So if you talk today to at least European governmental chief information officers, then in several countries, there is one big question: how should a governmental data architecture look like? Should it be centralized, meaning that you have your agencies, ministries, edges, nodes somewhere, and you pull data together in a central location to do something with it. Analyze, process, extract value, everything. Or you go for a distributed approach. You actually have the nodes talk to each other and exchange only what's needed. So there are ups and downs to both of these approaches. In the centralized one, it's intuitively easier to build. You pull together the information, you have everything at the same place, you can pick your technology easily, you can link, you can aggregate, it's easier. And also, there is hope that if you build this, then this will also take care of data quality. That's an expectation in several countries that we have talked to in recent years at least. Because currently what typically exists is you have these, they're called silos sometimes. You have these databases somewhere in the ministries, in the agencies, and what you want some sort of collaboration. The other approach, which is a more peer-to-peer one, not everybody might be talking to everybody, might not need to. You may have systems that are more popular, that everybody wants to talk to. For example, where people live, that's a pretty critical data store. And these fights are currently being fought in several countries in Europe. So, this is a story of a master's thesis written in 2001 on exactly this topic. And to anyone in the room who happens to be a student, may any of your theses have the same level of impact. So in 2001 in Tallinn Tech, a master's thesis was written titled E-State from a Data Security Perspective. And it was written in response to a discussion that was going on in society at the time, which was exactly centralized, decentralized. So both designs were on the table. Security analysis was written, but something weird happened. There was a request for quotes, a tender, and this pretty much, you could say, it asked for a centralized approach, but it had as an attachment the security analysis asking for a decentralized approach. In the end, the decentralized one was built, implemented. Security argument was a part of the story. There were some other aspects behind there, but today, it's a good story. We actually, in Estonia, currently have a system that keeps data separated. But if you're the data owner, if you're the Ministry of Internal Affairs, you are taking care of the police data, something like this, and this is yours. You're not giving it to somebody else for processing or analysis. They might come to you, though. So that's one of the stories. You actually were able to write a big risk analysis and convince the buyer that this is what they needed. Doesn't always happen. It's not always the big risk analysis that's time-consuming that wins in the end of the day. And that risk analysis was pretty much manual, ad hoc. You do is, it wasn't like a full cryptographic one. It was a systematic one, but not a crypto one. There's a reference at the end of the slide if you want to ever go and read this. It was translated to English in 2009 because people found out that there is great interest in this work. Second story builds on the first one. All right, assume you built a decentralized data architecture for your organization. Doesn't have to be a government. These days, many large corporations are the size of government. Right, so this one is a bit educational. 2014, that's a bit more recent. Estonia, may have the image of being a very forward-thinking nation, lots of technology, startups, a very developed government, all in all. But somebody has to build this. Somebody has to go and write the code, write the analysis, write the design. And these people come from universities. Quite a bit of them come from universities. Some are self-taught, some come from vocational schools. There's several sources for these people. But, so the statistics was a little bit bad. You had a graduation rate of around 40%. People coming in, IT students. In nominal time, you had 40% graduating. Where the obvious downsides of that are that if they don't graduate, they may not get all the skills. They may not become the high added value students. workers in companies, and they may not commit to the economy enough. So this was like a governmental level problem. There was, of course, the typical politics involved. You have, in Estonia, students go to work very early. My first job offer came in my first year, second term. The teaching assistant in the Java class, after having seen some of my homework, said that, would you like to come and work at insert company name here? So I actually went to that interview, young as I was, and but I asked them to be half time, but that was not okay for them, so I stayed at school, which was a great idea at the time. But it happens. So students go to work too early. And of course, you can ask the company's position, and some of them say that, yeah, it's a lazy student, we can't fix it. All in all, but this is, in this day and age, you hear about big data here, big data there. So let's solve this using big data. You have tax records. Tax records tell you where people work, possibly even how much do they earn, and what kind of company do they work at. Whether it's an IT company or did the IT student go and become a waiter. Nothing wrong with that, but it's still not what the government intended when they funded that program. Education records tell you when they have been studying, when they have been graduating, if not graduating, and so on. And if you could like just link these databases by person's IDs, you could obviously do the analysis, usual normal methods would be nice. Can't do that, data protection, and in this case also tax secrecy, that's an extra added bonus. This is a way worse requirement than data protection because you can have tons of exemptions to data protection. European countries can declare exceptions in the GDPR for law enforcement, national statistics, and ton of usages. But tax secrecy is a bit hard to circumvent. So what was it? We needed something else. Now I'm going to show you a cute trick. The cute trick is assumes you can do arithmetic from between 0 and 100. I believe we can all do that. And the trick is that I'm going to show you how to find the sum of two numbers without seeing the two numbers. Assume that you have a student who has an exam score of 25 and a student with an exam score of 33. You may want to find the sum or the average. If you have a sum and you know there were two of them, then it's the same thing. And on this slide, we have a seriously simplified technical description. We have numbers from 0 to 99. For people who paid attention in algebra, that's integer residue class ring. But to make it easier, think of it like this. You have only numbers from 0 to 99. And when you go over 99, you come back at 0. And conversely, if you go down from 0, you come to 99 and so on. What each data owner does is they pick a random number, 57 and 13, totally random, checked it myself. And then you subtract the two numbers from your secret. You actually get something like minus 45, but we remember we were actually moving in circles, so you get 55. And these 57, 13, and 55, these becomes your pieces of your secret. So the second student does the same thing. You pick a random number. Again, you can pick the same random number because if it's random, then it's random. And you do a similar subtraction. What you get is you get 44, 57, and 32 as the pieces. Now, if you want to check that you did the process correctly, you'll just add up all these pieces and you'll get back to what your secret was. You'll actually get back to 125 and 133 respectively, but you'll subtract the 100. And what you then do is you distribute the pieces among a number of computers so that each computer gets one random piece of each secret value. So the benefit to that is that you can easily show that none of these machines, the server 1, the server 2, the server 3, that none of these can actually access any of the source records. That's a simple number theoretic result. It's all random numbers, white noise. Now what each server can still do is they can add the two numbers they have. And when they do, they get a new piece of some value. And when we look at what the numbers add up to, it's 1, 70, and 87. We could continue adding numbers here. We could collect from 100 million more students, but let's stop here with 2 right now. And let's consider the server decides that this is fine. We calculated this. We can actually now publish the results of this calculation and give the pieces to a third party. The analyst receives the resulting pieces, which were 1, 70, and 87, one from each server, adds them together, get 158, 58 in our ring. And this is exactly 25 plus 33. That's a very simple trick. If you ask me how to do multiplication, it will take me 15 minutes to explain that. But we spent a little bit over 10 years on it, so we can do everything. We can predict whether satellites collide in orbit using a very similar paradigm, do floating point, do integrals, numerical methods. This is pretty cool stuff by now. So that was one of our biggest applications in the end. We got to link 10 million tax records and over 500,000 education records that were, let's say, encrypted or secret shared, as is the correct name for this operation, at the source, at the ministry, at the tax office. The protected values, the random values, were sent to 3 separate, non-colluding, independent organizations. The government agency, the Estonian Information Systems Authority, they do all the e-government work. Ministry of Finance IT Center, they are the tax offices, IT, and us. None of us could actually, even if we really tried, even like us having built the system, we couldn't get any of the secret values out of this. So this was done in 2015. And the nice result of all of this was that data never existed off premises. And then, once you have collected the data in such a way, you can analyze it using all the protocols. There's some heavy crypto lifting in there, but the point is that there was a special statistical tool inspired by the R tool, R environment, and you could use it to send queries to this multi-party computation system. And this system would check that this query is okay and would return the result if it was. The trick is that because you have multiple servers, then each of them can enforce the policy separately. So that if one of them thinks that, no, this query would publish too much, then they can withhold the result. And nobody else will be the wiser. They can't get stuff out, meaning that it's great for confidentiality, maybe less so for reliability. You can easily block certain computations. But if you think a bit, then this is what you sometimes want of confidentiality. You would like a computer which only behaves in your interest and that does not behave in your disinterest. You can actually stop it if it tries to do something that's not what you allowed it to do. So this is exactly that. Yeah, that was a success. They wrote the reports on that. There was no clear relation between working and not graduating on time. That meant that you needed follow-up studies. These were done using various methodologies, but the demographics change. Recently, we had a demographical, let's say, a little bit of a hole there. So the statistics haven't been exactly comparable over all the years. So we couldn't really answer the problem, but we created some very interesting precedents, and this allowed similar problems to be solved using the same technique. For example, we did a project where pupils with special educational needs, who need special teaching methods, we actually helped understand how they survive in the labor market later on, using, again, similar data sources, education and tax. Why is this cool? it's cool because the local data protection agency took a look at what we had built and said that after some serious thinking, that the combination of technology and processes ensured that personal data was not processed in the meaning of the law, which is a bit unintuitive given that you saw we did 10 million tax records, linked them by person to their education records. But in the meaning of processing in the Data Protection Act, no processing took place. Assumption here is that the outputs do not identify an individual, and that's a key one. The Tax and Customs Board also had to do something, and they were not fully content with just the Data Protection Agency's statement. They wanted to do a bit of a code review and test the system on artificial data to see how it behaves, because Data Protection Agency doesn't have any force over tax secrecy. This is to be enforced by Tax and Customs Board. So how do you convince the Data Protection Agency that you have a technology that's different from what's there before? And that's one of the parts that might also be interesting for this crowd. We imagined a new approach to how to do business process modeling. We tried to show between two different models what's the difference in privacy leakage. At that time, our notation was color-based. So for example, I'm not zooming this in, it's in Estonian, unfortunately. The orange part here shows that in this lane, in this process at this stakeholder, one of the lane is one stakeholder, there is a high risk of leakage for personal information. That surely some risky processing takes place at this party. Whereas in the yellow lanes, it's not as bad, and they potentially have control over their data. This is fine. And this was a bit ad hoc at the time. We needed to do something. We needed to convince the Data Protection Agency that there is something new here. And we thought that it might be nice. But it was very ad hoc at the time. It was a first attempt. It worked. We were very happy. So we thought that after that, we'll take this a bit further. So let's go more on with business processes. One of the things that had been going on at that time was privacy engineering. Privacy engineering and privacy by design, these words are heavily used in the General Data Protection Regulation, but they don't come from there. The whole notion of having well-engineered systems that respect personal information has been around for a while. Privacy by design, I think the trademark is held by Canada, by a Canadian organization. And things like data minimization, that you should actually build systems that process as little as possible to fulfill your business goals, not as much as you can get your hands on, has been in the OECD privacy principles for decades now. And there have been attempts at creating guidance. How do you build these systems? Because it's not obvious to a person. The obvious thing to do is, okay, I have data here. I will now apply this processing method on it. Results, voila. But again, it doesn't go with the philosophy of privacy and security. And again, regulations such as GDPR, very enlightened ones, they try to solve a problem that's created by insufficiently mature technology. So there have been attempts on trying to create guidelines. Some of them are in ISO standards. One of them is Privacy Architecture Framework, which I had the honor of for several years. That was a very hard discussion. So everybody agreed that you have components, you have technologies, you have encryption, you have pseudonymization, you have anonymization, you have query restrictions, you can do some sort of safe rooms where you go in, you can't take any data out, lots of things. But how to combine them into an information system in a reasonable way. So this particular standard came up with a number of components and gave architectural views of how do you reason about these components in your information systems architecture. There is another ISO standard which standardizes architectural views for information systems, so we built upon that. What happened in the end was we only got the building blocks defined, but not the process on how to choose between them. We really tried. ISO is an international organization, means that everybody's in there. All the big countries, all the small countries, and it's a very democratic process. Everybody, one country, one vote, doesn't matter if you're the US or Estonia. But no country, no national body came up with a good process on how to choose the technologies for your architectures. We tried cooking something up, but there wasn't maturity there at the time. Given that this was published 2013, I think the discussions went on around 2010. And we didn't come to this community at that point. We should have probably done that, because I guess you would have been able to help. But limitations. This work group was mostly filled with security people, not so much software engineering people. And yeah, we lost out on that one. Given what I've read recently, then I've understood that some of the ideas are already in literature for ages. But need to have a collaboration between disciplines. That's certainly a result from this. So, what we did, after we had done this privacy-preserving statistical study, we thought that, okay, this approach worked rather well. Can we industrialize it somehow? So with some good collaborators in the University of Tartu, we came up with privacy-enhanced business process models, which tried to do the same thing that we did for the Data Protection Agency, but in a little bit more formal and correct way. So here I'm making toy examples. Don't dig in too much into the syntax on this one. This is meant to explain the whole concept to people who are not in this community. So think of it, there are two swim lanes, two stakeholders. One of them is the payment processor, and the bottom one is somebody who profiles customers. Maybe for that processor, maybe they are just selling the data, and so on. So the payment processor has transaction data. It's in their operational information system. It's happening all the time. Every time you do a transaction, there is a record created. So what happens in a classical information system is you send the data to the profiling organization. With any luck, you do it over a secure channel. I wish everybody did this. Not everybody does at this day and age still, I think. But if you do that, if you have here the label that this is done over a secure channel, then your risk analysis can take this into account later on. At the profiler, you receive the data, the transactions, you put it into a profiling task, and you get the profiles. So this person's car lease has run out. So we should really start showing him or her more car commercials on his TV, something like that. This is what happens all the time, and that's the result. That's the output of the process. Well, the profiles, whether there are privacy infringing, is a matter of policy and regulation. So all in alone, these diagrams don't help us much. But if you overlay them on top of requirements, whether business requirements or regulatory requirements, then you can start asking the correct questions. For example, you can ask the questions whether the transactions file present in the second swim lane should be there. If there is a regulatory requirement, transaction data from the payment processor should not make it to the customer profiler. then maybe it's a risk. But it has to be checked against a certain, let's say, risk profile. Maybe it's totally okay. In many cases today, it's just done and nobody finds this a problem. But you can show these things. You can make a table that this stakeholder will have access to this data object. And when you start using these security technologies, the table will become more complex, but I'll show an example first. So this is a second slightly amended model, but goes at the same business idea. You have a payment processor who encrypts the transactions before sending them over a secure channel, meaning that there's a bit of there's a double encryption here, but bear with me, there's a reason. These days you can build computers that process data without seeing them. Imagine the previous example I had on tax and education data. So you can model this into your business process. You can say that, all right, this task is executed using secure computing and means that you put encrypted transactions in and you get profiles out. And the key part here is related to the actual key, the encryption key. It doesn't have to leave the payment processor. So this is not a fully cryptographically correct diagram. The key that was used to encrypt the transactions, this won't be available to the profiler. Because yes, when typically today we talk about encryption, we understand it like this, that I encrypt something, I send it to you, you decrypt it, you process it using your normal tools. So with secure computing technology, you can build these secure by design solutions where you won't have access to the decryption key, but you will still be able to do processing. Hoping it will be a game changer one day, fix some of the problems from 1940s. So there's multiple different privacy techniques you can model here. And we've been trying to build tool support for this kind of modeling. It is complicated, but the problem is that not everybody has higher educations in cryptography and privacy technology. So some tool support, some guidelines are needed to make this into a solution that proliferates, that actually goes into the community, that system analysts start to use and so on. So in order to eat our own dog food, to actually do what we preach, we are applying this in practice now quite often. So in 2016, a biotech company who had commissioned a design for a cryptographically secure healthcare data querying system asked us to come in and perform a security audit on that scheme. Was it done well? If they implemented it, would it achieve their security goals and adhere to regulatory requirements? The system was presented in a cryptographic manner, algorithms, some hints at which party runs what, but it wasn't mapped out to actual stakeholders. So what we did was we mapped the whole process out using this business process modeling methodology. And this allowed us to clarify what the data flows were, which data objects were accessible to which stakeholders. And if we put all this picture together, if we filled in the matrix with this party will have access to this data object, and this data object, then through some analysis, we saw that maybe not from each data object alone, but by combining several of them, a stakeholder in the system could learn more than allowed by the security requirements. Meaning that this was for us, this was an important finding because in computer security and cryptography, you often write down the protocols and data exchanging using sort of algebraic notation. This party sends a message to that party. It's all very beautiful. You can formalize it and analyze it in tools, but it's not always the physical world deployment. It's not in there. It's not supposed to be in there. But here we got that into the model as well, and it allowed us to find the problem. So yes, we showed that the design was broken. We got to design a new system. That was a challenge, but got it done as well. So one of the first applications we've seen to this method is exactly auditing existing systems, showing where they leak. Of course, then comes the fixing part. Once you found the leakage in your pipes, you have to go and fix it. So we are now also designing new systems with it. It was similar to the initial goal we had on that the governmental statistics task. So we helped this year. We have worked with an Estonian government customer on a risk analysis for a statistics analysis system, statistical system that needs to pull together data for the next large census, which is supposed to happen on national registries. Not that people go to other people's home and start asking questions, but everything is pulled together from the registries over the same infrastructure I showed you earlier. So, but the nature of that data is slightly different. It's cell phone location data used to understand whether people live where they say they live. Because if you declare to your government that I live at this address, then the government provides you certain services at this address, kindergartens, schools, something like that. But if you actually live elsewhere, maybe you want to optimize where your kid goes to school or something like that, then the government would need to know. And if they don't send somebody to find you at the address, then they will need to find it out using other means. And it's not necessarily a surveillance situation. You just need to know how big of a percentage of your population registry is incorrect. That would do. For statisticians, that does it. They know what their error bounds are for everything else they do, whether it makes sense or not. So, but this is a tricky situation. There's not only GDPR affects that, there's also the electronic communications regulation that has to talk about message secrecy, and e-privacy is currently under discussion in the European Commission Parliament as well. So again, we did the same we did in 2014 with the tax and education data. We modeled the system as it would be built today, because that was the system that the data protection people said, you can't build this. It would be an infringement on people's rights. And then we modeled the system with newer technologies, because technologies develop still all the time, and showed how the leakage is smaller, how there is a minimized set of data becomes available to the statisticians, how the infringement potentially doesn't happen. I would like to tell you that we have a response for that. This is currently still, we're sparring on this with the legal people. But I'm hopeful that we can do this. Because the thing is, what I see around the world is some countries don't really care that much about privacy. Certain countries in Asia just collect the data and do whatever with it. Might give them an edge. So my hope here is that we can somehow get best of both. You can get the economic edge, and you can still get some fundamental rights for people. All right, so start concluding this. This is going to be a bold claim. I'm going to explain why. I think GDPR is one of the best things to happen to the information systems engineering community over a pretty long time. Why? It actually forced change. It doesn't magically make systems more private or more secure, but people in companies and governments had to start thinking of what data they do have, because the regulation forces them to do so. And now you you are looking for methods which you can use to map out what data you have. You can go at it analytically. You can look at all the systems analysis and the business process analysis you have on your information systems. Yeah, right, not everybody does that. But search engine technology, you can have little spiders crawling around in your network drives, databases, and coming back with the results that, hey, you look as if you have credit card numbers here, here, also found some that log. Right, so these are helpful tools. There's a number of companies who does that right now. That's a great reuse of existing technology for a new reason. Also, some of these people, after they've crawled this out, they put it on the blockchain to be sure. The second part, which is way cooler in my understanding, is people need to understand what kind of processing takes place. Understanding what data you have is like the first entry-level step. What actually the regulation requires is you know what you do with the data and whether you have consent to do this. And there is actually a company that suggests to use process mining to actually go at your systems and do process mining and understand what kind of personal data processing takes place. This is way cool, I think, because indeed, some organizations, mature ones, have models available on what kind of business processes and data they have, but processes mining is something I've tried to find good applications for several years, and I still think that an artificial test data generation is out there. So if somebody's doing that, do let me know. I would be very interested. Also, the general maturity of information systems is improved because there is investment. And when there's investment, then sometimes stuff gets better everywhere. Even companies that aren't security companies today are putting GDPR into their marketing materials. And why? They say that we'll analyze your system, we'll help you be compliant with the GDPR. But on the side, they get to come into your organization, they come to understand your business processes. They can also tell you that that information system leaks too much personal data in the logs, which needs to be re-engineered. We'd be happy to do it for you. So this is going on right now in this sector. It's very cool stuff. That's why I think that GDPR has a great effect. Sometimes the systems that get built are more actually protect privacy better than the previous ones. Sometimes you just do legal loopholes and don't change anything in what you work, but you actually get better systems. You get systems engineered with a greater level of maturity, with more modern tools. Hopefully something that comes out of this community here. And if it gets to be more private as well, then I'm happy about that. I'll consider this a small victory at least. So what we have come up with over these years is if you want to build a secure system on insecure foundations, then there's three critical components here. You have to build from secure components. Understanding whether they are actually secure is a whole separate debacle, because sometimes even if they're certified, they may not be correctly implemented, but that's a separate discussion. Composing secure software components into a secure system, that's an art. So once you've built it, you need to do a risk analysis. You need to understand what's your residual risk. Maybe somewhere in between the components you have leakages. Maybe you have leakages in the outputs. It's not only the inputs that are confidential, the outputs can be confidential as well, as we learned in the taxes and education case. So the key to proliferation is that you can teach. And to make these skills transferable, we feel there have to be tools and there have to be guidelines, maybe even some patterns. But with patterns comes a risk of what's called cargo cult programming or cargo cult implementations, where people blindly take something they see on the internet and think that this resolves their problem as well. It might, but again, without the risk analysis, it doesn't really give you a good guarantee. And in the end, you will have to find someone who actually goes through the effort and adopts the technology. If it's a new security technology, if it's a new software engineering approach, you have to get a customer to do it. For example, our company does also not only security technologies, but we also do engineer information systems for mission critical use, taxation, customs, so on. And we actually had a customer at some point who came to us and said that we've heard about this BPM thing. We would like to build a system on a BPM engine, everything done properly. And we were really happy to do that. We learned in the process, the customer learned in the process. I don't know why they did not ask for another system based on this technology. Possibly either we did a bad job or they did a bad job at asking, or they liked our other systems better. I'm not sure really. But you need to educate the customer, because maturity among customers is not always good enough. GDPR helps again. So what we do if we want to tell a good security story, we try to avoid selling through fear. A lot of security vendors try to sell security through fear. Do you know what will happen if you're not compliant? You will get this 6% of your international global revenue fines from the European Commission, blah, blah, blah. Yeah, but it paralyzes people. It makes them go to tunnel vision and does not make them see clearly. We try to align innovations with growth strategies. If we know what are the corporate goals of a company or where the government needs to go with regard to its policies, then we try to align the innovations with that clearly. And that has helped us. So there are references in these slides that you might be able to see later on the video, or if you get the slides somehow. The first is a master's thesis. It's available online. The second is the case study for that taxes and education paper. That's an open access paper. And the privacy enhanced business process modeling paper. Not sure that was open access, but some of you folks probably have the proceedings from BPM 2017 around. So you might get it from there. That's all from me. Do I need to put? No. Okay, thanks a lot, Dan, for a very interesting presentation. Time for questions? Okay, one thing, yep. And please just say your name, because no one knows everyone. So, just make, yep. Microphone is coming.
Hello. Thank you for the presentation. It was very, very, very interesting. My name is Alexander. I'm from Sorbonne University. So I have like 3 questions, but maybe for some of them you don't have an answer. It's like small question. The first one is, do you have information how the cost of security have changed after GDPR for the enterprise?
So the question, I guess that was heard, but how has the cost changed after GDPR for security? I'm not sure. It depends on which budget you put it in. Some people put GDPR in the security budget, but whether it fits there is a different question, because you actually need business process re-engineering. You need to change your business processes, so it's not so much your security budget, but it should be your business process budget. But I don't have too much insight into that right now. I've seen the prices of several GDPR products, and they all assume that the customer has lots of money.
Okay.
Yeah.
Thank you. And the other question would be, what would be your short, mid, and long-term focus as the service, like cybersecurity service provider?
In a really long focus, I would like to be like in Star Trek. It's a nice society where nobody has to be afraid. There might not even be money around. People trust each other. Life is nice. You colonize other planets. But in the medium and short term, I think that we may need to overcome some of the trust deficiencies with technology, because some things computers can enforce. I'm still a believer in that. So helping build better systems is something that we are focusing on, at least. And I think that there was I don't have a perfect citation on that, but a slide was recently shown by one of the big 4 consulting companies at a US privacy event. And it showed the relation between privacy maturity in an organization and the spending. Companies that had that a higher level of privacy maturity in their processes spend a lot more on privacy, which is logical. You know what your problems are, but everybody else, they don't know what they don't know, meaning they don't spend right now. But maybe this will change in the coming years once people start seeing potentially the first fallouts from GDPR enforcement.
Thank you.
My pleasure.
Thank you very much for the talk, and thank you for coming. I I kind of was wondering if it will be all this technology you present is very complicated for,
Yes.
looks very complicated,
It
right?
is.
I mean, it takes so many slides to add one number. So I wonder if there is any hope that in the next 5 years there will be a technology such as secure computation or privacy aware computation as a service, privacy as a service, that you are an agency or you are a company and you install some sort of certified wrapper and you can connect one or several tables from your database into it, directly, say from your Oracle database, and the other people with whom you want to cooperate will do so. And then these wrappers will do all these magic, send some numbers to a central cloud server, which will calculate, and then you can certify this is secure. Meaning, of course, the outputs have to not convey personal data. So the queries you make over this privacy as a service querying service, private querying service will have to be approved, but provided that that is the case, that the outputs do not reveal anything, you can certify that this is GDPR compliant, can I dare say.
Okay. There's two things here. First of all, when it comes to output privacy, things like people selling you products that promise that they'll make your database query results private by adding noise, because that's the only mathematically proven way how to get privacy from your SQL queries, for example. You just make the results noisy, so even if you slightly change the input parameters, then you might not be able to identify a record in the database, but you will get incorrect results. There's several products out on that, but these are, I don't trust in them very heavily right now because they get broken every now and then. And if you have access to certain auxiliary information, then you will be able to deduce something from the database. It's a so-called Washington Post front page attack that if a journalist can use a query interface to determine one personal data piece about a citizen, then your system will have a major reputation problem. It was like when Netflix did, not Netflix, but there was, Netflix has also done these give data out, let the data mining community analyze it and give us new interesting methods how to predict what people want to see. Turned out you could identify people out of it. It's like 3 or 4 movies you have seen, you can be identified. Like individually, unless you really look only the very same movies. But even the mainstream movie output right now is so large that nobody or few people see exactly the same number of the same movies. And so that's a problem. I don't see a good solution for that. I haven't seen very good impossibility results in literature, but in practice, I would always go with some restrictions, as you mentioned. So automatically, if something says that will automatically make query results private, then take it with a grain of salt. And also you will have to take it with a big grain of randomness in your results. As a second question, when there will be services. So what I showed, this nice little toy numerical example, that piece of technology is complex to deploy. That's correct. So I have expectations on certain new upcoming techniques, which have their security assumptions, of course. Every security technology comes with assumptions. For years, processor manufacturers have tried to build trusted processors, trying to fix what was done wrong in the early ages. And there have been these trusted platform modules, trusted execution environments, Intel's TXT, ARM's Trust Zone, more recently Intel's software guard extensions, SGX. And I believe that these will become mature enough that you can build a cloud server that doesn't see the data it's processing using hardware protection mechanisms. Even if you have physical control over the hardware, you cannot look inside the process, you cannot decrypt the memory because the keys are held inside the silicon. And you can remotely attest that this processor is running the code with this fingerprint inside this secure enclave environment. This is currently entering the market. The servers, Intel will have servers available third quarter this year. There are already a couple of first cloud providers offering this kind of hardware, IBM being one, and Microsoft Azure has put out a ton of press releases that they're going to be doing this. Amazon is still silent on that. But this technology might change something because it's easy to deploy. It will be ubiquitous. I don't know how new this laptop is, looks rather new. This laptop probably has that kind of chip inside already because Intel started rolling this out for desktops, laptops like 3-4 years ago. And it will become ubiquitous. So you won't need to buy special hardware. It will be in all the servers, and that might change something. There are several companies building platforms on top of that, including us, disclosure. And I think that this might change something. But the problem is not so much in technology, but processes, actually. Changing how people want to work. In this statistical application, we had to convince the statisticians that they will not see the data records. You know how painful that is. These people are taught at schools to look at the data and each individual value. You can't defeat that training by saying that, hey, we have now this privacy. You can now only interrogate the data. You can't see the actual values. There's a lot of kickback on that. And especially when you go to either pure statistical applications, when people are used to exploratory data analysis and trying different tests and everything, and law enforcement applications, because these people sure want to see all the details on all their applications. But if you go more into this machine learning, AI, very big data things, then it doesn't really help you if you look at 2 records in a terabyte database. It gives you nothing. You need aggregations anyway. So there, I think there's a great shot that this will actually work. That was a long answer, but you had a long question. Yeah.
Yes, please. And remember, say your name.
Thank you for your presentation. I'm Aya from Panthéon-Sorbonne. I have a question about, I know that Estonia is a digital nation, and you use blockchain for e-residency. So I want to know is it compliant with the GDPR or not?
We surely use blockchain for e-residency marketing. Whether we use blockchain for actual e-residency is, there are, so let's dissect this statement. There are service providers who provide certain services to e-residents that use blockchain as a fundamental component. This is true. In the governmental data exchange platform, there is a technology called timestamping under every digital signature and every transaction that's digitally signed. And timestamping as a technology cryptographically is very similar to blockchain, but it was there in 1990. Some companies that used to do timestamping, when they found the blockchain hype, they quickly pivoted and started calling what they do centralized blockchain because it helps with business. I don't have to tell you that blockchain is really hype right now. You probably noticed. So there are technologies that are similar to blockchain in the Estonian e-government platform. This is true. And there are services in Estonia that are based on blockchain. I think these both statements are correct.
But is it compliant with the GDPR or not?
That's the second great question. So the digital signature part, that's not a big problem because centralized blockchain, the timestamping systems, you don't actually put data into the signature. You put a hash from which you can't reasonably deduce what this input was. The services that are based on the actual decentralized blockchain, I believe these are mostly not related to personal data. But I can't be sure because these days I can't keep track of all the startups that are there in Estonia. I know a few. Funderbeam, I know, has a reasonable use case for blockchain. They do it to track investments in startups, funding decisions, things like that, and the stakes in organizations. That's sensible. From all the legal analysis I've read on the compliance between blockchain and GDPR, it's a hard question. If you want to enforce the right to be forgotten, right for erasure, then it gets very complicated because your technology is technically erasure resistant. You sometimes can't even overwrite this. In those cases, yes, you can't be. However, I've talked to a couple of lawyers on this one, and because I had the same question, and they say that it depends if you can. There's so much flexibility in GDPR. If you can show that it's infeasible for you to do so, then you might get an exemption. Infeasible meaning like you can't possibly. It's impossible to remove that data without, I don't know, corrupting 4 governments or something. So I have my doubts in blockchain as a privacy technology. Sometimes it's sold as such. I think this is incorrect. You shouldn't do that. You're not doing this, but generally nobody should do that. And I think the answer to your question is probably towards the no camp, not fully compliant. But I'm not a lawyer. Please get professionals who actually went to university and studied law. Didn't do that one. We hired a lawyer because we couldn't do it just with crypto people anymore. We have a full-time lawyer in our organization, just helping us decipher all these regulations and the place of our technologies in regulations.
Because I have this question because I work in the bank in BNP Paribas in Paris, and then we have a process which called KYC.
Oh yes.
Yeah.
Know your customer. Yes.
Yeah. And as a solution, I want to propose something like blockchain, and I don't know if is it compliant or not, because I read many articles about that, and I see that it is not compliant, especially with the Article 17, with the erasing of data.
Yes, that's the hardest one. The first thing you should ask yourself when you're proposing a system like this is, do you want to do KYC or do you want to do blockchain? Sometimes they don't make each other better. So you have to figure that one out, whether they actually mesh. Maybe there are other ways. Blockchain is a database. Maybe there's a different kind of database you can use that's erasure resistant. Could be.
Thank you.
Morning, Håkan Enquist from Gothenburg. My opinion on your presentation is a question of privacy, but I'm still in the room, so you make your guess.
Thank you.
There is a notion of information resource management, starting in the organizations actually trying to pursue their business. And that's where you define the value of data. And with what we have presented today, we can see that you now can work with much more granularity in sets of data with different levels of protection and different levels of value and so on. And now, since you've been working with a lot of organizations, what's your impression of their maturity to actually work and define data value from the business point of view so that they know what to use your tools for? I guess you understand the question.
Yes, perfectly. Organizations who have an integrated management system which is certified under ISO IEC 27001 standard, which is the information security management standard. These people understand their data assets and their values to the business processes. That's a nice thing. You know, you go to an organization, it's in the standard, they have to list their data assets and their which ones are critical, which ones have to be protected, how heavily. These organizations are all good and fine. If you meet one of those, then they should know. For them, GDPR is going to be way easier. But again, everybody else, less so. You can go into very data-heavy organizations like research organizations. You could go like medical research. They don't know where they keep all the copies of their patient files always. Even though they have a ton of data, they should have all the maturity, but they actually may have, oh yeah, I changed a little bit of this here, I left it there on that HPC cluster. Oops, maybe I should have told someone I have 10 terabytes of patient data there. Can happen. It will happen again. Yeah. There was a question here.
Sorry.
Yeah.
Okay, this is brief. Steve Alter, University of San Francisco. We've had several hundred pictures taken during this presentation. I wonder what the GDPR says about the use of those pictures. And for instance, I have my name tag here, and I wonder how annoyed people would be to be associated with me through those pictures, et cetera, et cetera.
Marlon, you're trolling. The question is very valid, and it has been discussed, I think, in the European Parliament for a lot. Also regard to copyright, all of this right of taking a picture, because some very strange things started happening. Copyright folks, for example, can you take a picture of the Eiffel Tower and post it somewhere? It's so that discussion has been held extensively. Technically, I don't know. I managed to somehow bypass the registration process here, but for everybody who actually went through the registration process, were you able to put check marks somewhere? Agreed to some terms and conditions? No. Okay, then yeah, I don't think these photos can go anywhere. But sometimes when you go to places, then there are these very clearly written out terms and conditions. We're going to take pictures of you. Yes, yes. Yes, and this is, by the way, something I've seen a lot more in the United States, because there's a different playbook on privacy in Europe and the United States. Both actually care. I saw this in my standardization years. The playbooks between Asia, Europe, and North America are different when it comes to privacy, but it's not like America doesn't care. It does it differently. But your question, you probably, your level of seriousness, I could not fully deduce from that, but I'm assuming that I can't answer that fully to your satisfaction.
Thank you for your presentation. I'm Selmin Nurkan from Sorbonne University, and my question was regarding the slide where you put this number calculations.
Yes.
And I was wondering whether I think also that the fear is not a good friend for anything, but awareness is required.
Yes.
So I was wondering whether your message in this calculation was to tell us that the total secrets in a connected world is not possible. Because I assume that having the sum, a third person can understand that if the maximum grade is 100, and if this person would like to hire these two guys only based on knowledge excellence, he will decide to not hire them.
Correct. So actually, if you look at the example perfectly, then this is not the case, because because we were working in a modular 100 ring, you could actually have these scores be 99 and 59. That's one of the tricks.
Thank you very much.
Yes, that was one of the tricks. But actually, sorry, there's a second part to this. You touch upon a bigger problem, which is exactly what's the impact of outputs. The GDPR defines something called the privacy impact assessment, which is supposed to be the risk analysis process to all this. It doesn't get to the level of maturity I would like it to be. And there's also ISO standards on that one, and people who can do this. Basically, what they try to do is, okay, if we publish this information, potential impact on the persons whose data we're publishing, which is exactly what you touched upon. And it goes to the point of AI profiling, all of these things that are very hot topics in universities right now, where you are worried that if machines start putting people into jail, then it better be very honest machines, right? And very transparent machines, because if you're doing, there's two sides there as well. Law enforcement applications, they would like to get all the data and you would like to get the suspects out, but it will, in my opinion, it will have to be a human being who makes the final decision based on as much information as they can get. So if I were ever to roll out secure computing in a law enforcement scenario, then I would use it for suspect generation only. And then once there are suspects, you start an official investigation when you are now legally allowed to collect data about the suspect, because you have maybe the police or the taxation officer rights to do so. And then you can do a, let's say, a human decision. It will be more transparent, but I don't want to go into the Minority Report kind of situation. Science fiction novel by Philip K. Dick, which describes a society where basically at some point in a police department, your name comes up and says that you're going to commit a crime in the next 24 hours. Pre-crime unit, it's called. So I'm hoping we don't get there.
We are running out of time, but we have time for one last question.
Sure. Hugo Lopez from IT University. Thank you for your presentation. So well, when it comes to compliance, compliance seems like the antagonist. Well, when compliance and security seems to be the antagonist of business processes. So while the business process trains to maximize the consecution of business objectives, then security and compliance them or blocks the development to preserve certain rights. What you're saying here is that you are presenting this as an opportunity to grow. I would like to, if you can explain this a little bit more, instead of the kind of selling by fear, selling by growth. I like that.
In large banks today, there were at least some people from banks, like 10-15% of the whole budget goes on compliance departments, or like whole floors filled with compliance people. Yes, it's a major cost aspect right now, but the thing is, for example, let's look at this ShareMind thing. That's not a compliance technology. You can comply way more easily. You get consent from everyone, or find an exemption in regulation. That's what happens in most of the organizations. And that also comes with the expense of lawyers and people who regulate, who lobby the governments to pass certain regulation. Technology is an alternative cost to this. And it will come with the offset of potentially reducing your liability. If you don't have access to that data, mean you don't have the capability to minimize it. To leak it. Meaning that your liability with regard to such events should be reduced. Maybe your insurance premiums should be smaller, because you've actually thought your system out way better, you have a higher level of maturity, there's a way smaller risk of you actually leaking something out. So if you start looking at this from alternative costs that are being paid today anyway, then it might be a great deal. For example, but there's also counterexamples. Think of a whole electronic payment situation, credit cards. It used to be a totally insecure platform. Instead, you collect enough fees that when somebody has their card stolen, money taken, you just get your money back from that fund which they keep for the dark days. So why make the system more secure where we can just, pay the damages? So one of the things that GDPR is changing is paying the damages gets very, very expensive. For multinational corporations, it's the up to 4%, 6% of their global revenue, not like Estonia local revenue, but international one. These damages will be damaging, meaning that there is incentive there. But you have to look at this as alternative costs. You have even a compliance department, or you have machine enforced compliance, or you just don't do anything and hope for the best. But mature organizations can't do the latter one, more like startup thing.